P is the incenter of triangle XYZ. Find each measure. So here we have our diagram, and we want to find the length from P to K. We're going to use the incenter theorem. By the incenter theorem, because P is equidistant from the sides of triangle XYZ, same distance, PK has to be equal to PJ. Let's go back to our diagram. PK has to be the same as PJ. Using the Pythagorean theorem, we know that PJ plus 5.6 squared, PJ squared plus 5.6 squared equals 7.3 squared. So let's go back up here again. So PJ squared plus 5.6 squared has to be equal to 7.3 squared. So they're looking at this little triangle right here. And they're going to use that to find the distance from P to J. So squaring the 5.6, squaring the 7.3, subtracting from each side, we get that PJ squared is 21.93, the square root of which is plus or minus 4.7. Because we're talking about length, we don't need to worry about the negative answer, so we're just going to look at the positive, which is positive 4.7. And as stated before, PK has to be the same as PJ, so since PJ is 4.7, PK is also 4.7. Next, we want to find the measure of angle LZP. I'm going to minimize this one so that it makes it easier to see our diagram. So the measure of angle LZP. So we're looking for this little angle measure right here. Again, P is the incenter of our triangle, our big triangle. So XP bisects LXK. XP bisects LXK, right? It bisects this. Let me get my pen out here, make it a little bit easier. So we know that this angle is congruent to this angle. So one of them is 24.6, so the other one is also 24.6. YP bisects KYJ. YP bisects KYJ. Grab a different color. So we know these two angles are congruent. One of them is 25.1, so the other one is also 25.1. And ZP bisects LZJ. So grab one more color. So we know that this angle and this angle are congruent to each other. Thus, the measure of angle LXK is equal to 2 times the measure of the angle PXK. So LXK is 2 times 24.6. So what they've done is they've looked at this entire angle, and they said that the entire angle has to be 2 of these guys, right? Because they're both 24.6. So you add them up, or you go 24.6 times 2, however you want to think about it, and you get the whole angle. So let me go back to blue. Talking about the whole angle here. Then they do the same thing for the other angle that we know, the 25.1. Let's go back to my red color, this whole guy here, right? So now we know from our big triangle, we know 2 of our angles from our big triangle. And I'm going to scroll down here, and I'm going to redraw the triangle, not to scale or anything. So we know this one is 49.2, and we know this one is 50.2. So now we can use that to find our missing angle right here, because the triangle sum theorem tells us that all three angles have to add up to 180 degrees. So using our triangle sum theorem, knowing that they all have to add up to 180 degrees, we take the 49.2 and the 50.2, we add them together and subtract that from 180. That tells us that this mystery angle over here is 80.6 degrees. Now, if we look back up here at this guy, if this whole thing has to be 80.6 degrees, and we know that it's being bisected, we know that each of the little pieces has to be half of that amount. So we're going to take our 80.6, we're going to divide it by 2, and that tells us that the measure of the angle LZP that we've been looking for this whole time is 40.3 degrees.